All right, we'll pick it up again here. Sorry for that interruption. So where we were right here, we were setting up this right triangle based on the information given to us. We got 5 on one side, root 3 on the opposite side, and the hypotenuse is root 28. When I plug in the sine and the cosine into my double angle formula, 2 sine cosine, those fractions just get multiplied out to give you negative 10 root 3 over 28, 2 times 5, negative root 3 on top. So negative 10 root 3 on the top, and root 28 times root 28 is just 28. So that reduces down to negative 5 root 3 over 14. The next problem uses cosine double angle formula, which is cosine squared minus sine squared. So I already know what the cosine is. It's 5 over the square root of 28. And I know what the sine is. It's the square root of 3 over the square root of 28. So I square them both, subtract them. That gives me 25 over 28 minus 3 over 28. That's 22 over 28, and that reduces down to 11 over 14. The next problem, part C, uses the angle addition formula for cosine, which is cosine, cosine, sine, sine, and that's a minus subtraction in there, so this is plus addition here. Cosine pi over 2 is just equals 0. So cosine A times cosine pi over 2 just equals 0. Sine of pi over 2 just equals 1, so sine of A times sine of pi over 2 is just equal to sine of A, which is, according to my little triangle right there, square root of 3 over the square root of 28, which of course in quadrant 4 is negative, so I have negative root 3 over root 28. I could rationalize that, but for time and space considerations, I shall leave it like that. The next problem, last problem, again, I'm going to shortcut a little bit just due to time and space, but this is using the angle addition formula for tangent, which is tangent A plus tangent B over 1 minus tangent A times tangent B. So when you kind of look at that formula, hope you've got it somewhere written down to compare, but this is how it will set up. Tangent of A is negative root 3 over 5, and tangent of pi over 4 is just 1. So negative root 3 over 5 plus 1 over, and then we have 1 minus the product of those two tangents, which of course one of them is just 1. So it's 1 minus negative root 3 over 5, which of course is 1 plus root 3 over 5. Now my next step, what I did was I multiplied the top and the bottom by 5 to get rid of that little fraction there, having a denominator of 5. So that gave me, 5 times this is just negative root 3, and 5 times 1, of course, is 5. So negative root 3 plus 5 on the top, and 5 plus root 3 on the bottom, or root 3 plus 5 on the bottom. Now, what I'm going to do is multiply the bottom of this fraction by its conjugate so that I can rationalize the denominator of this fraction. And I'm taking advantage of this universal truth in algebra: a plus b times a minus b always and forever will equal a squared minus b squared. So I take advantage of that fact by using the conjugate of that expression on the bottom. Root 3 plus 5, the conjugate of that is root 3 minus 5. So I do have this a plus b times a minus b thing going on here. And so that's just going to give me a squared minus b squared. Well, that just gives me 3 minus 25. So my denominator of this fraction, which is what I'm really doing it for, is 3 minus 25, or negative 22. So let's stop right there and then talk about the numerator. So when I multiply the top times the top here, that's negative root 3 plus 5 times root 3 minus 5, and that's just using the FOIL method. Remember, I'm just multiplying that binomial times that binomial. So it all works out this way. It may take a few seconds for it to sink in, but when I multiply all of this, I get negative square root of 9 plus 10 root 3 minus 25. Okay, I have to think about that for a second. That reduces down, since that's just a negative 3. Negative 3 and negative 25 is negative 28. So I have negative 28 plus 10 root 3 over, and my denominator was negative 22. So that fraction does finally reduce down a little bit to negative 14 plus 5 root 3 over negative 11. I could go further and kind of mess with these negative signs here, but I'm just going to leave it like that. The last problem is using the angle addition formula once again for tangent. It's a mess, so it's good to practice. Here it is more spread out. Tangent of 75 is the same as tangent of 30 plus 45. So I'm writing it as tan 30 plus tan 45 over 1 minus tan 30 times tan 45. Well, tan 45 equals 1. Tan 30 is root 3 over 3. So my top of the fraction here, root 3 over 3 plus 1 over 1 minus root 3 over 3. So I've got a similar situation in this problem as I had up here. All right, but anyway, I'm going to change this 1 to a 3 over 3 so that I can combine these two things into one fraction, root 3 plus 3 over 3. The bottom, I'm doing the same thing. 1 is the same as 3 over 3, so 1 minus root 3 over 3 is the same as 3 minus root 3 over 3. Now, I have this fraction on top divided by this fraction on the bottom. These two denominators being equal will cancel each other out. That leaves me with this fraction right here, 3 plus root 3 over 3 minus root 3. So it's a very similar situation that I had on the top of that previous problem. Again, I'm going to multiply by the conjugate of the denominator, which is 3 plus root 3. Once again, I'll get a squared minus b squared. That just gives me 9 minus 3. So this is a little bit simpler problem. And then on the top, I'm multiplying each of those things together using the FOIL method. 9 plus 6 root 3 plus 3, that's 12 plus 6 root 3 over 6, which reduces finally down to 2 plus root 3. And I think everyone would agree that that is a better way to write that compared to that fraction there. That's kind of a mess compared to that. Okay, that'll do it. We'll see you soon.